So in this video, I'm going to quickly go through the development of an iOS demonstration app I recently developed. The app encapsulates three core libraries: SwiftUI for stateful UI, SpriteKit for 2D simulations, and SceneKit for 3D simulations. Here I'm operating a build of the finished product on my phone, which is exhibiting some important features like animations, 2D gameplay, a 3D render of the tap results from the gameplay, and stateful data being passed around the application. To begin, I set the overall project environment, such as a constant class that helps make code cleaner to read and alleviates the risk of incorrectly typed strings. Alongside constants, I supplemented UI color class with an extension which allowed me to use hex codes from my color palette and generated a global enum for handling the screen, and constructed an observable object for the project state, which can be then accessed by all children of a top-level parent view that sets the environment object as the state data entity. Afterwards, defining 4 pass-through subject events from the combined library, which broadcast data from a class to send state updates to the view. This is necessary as only views can work with the state and observable object property wrappers, using event publishing and subscribing to communicate effectively. Next was to set up a top-level view that contains the child views to be switched between. Content view holds the current screen enum bound by a state property wrapper, which is then passed into child views as a binding property using the dollar symbol. This allows all views to set the exact same referenced enum property and cause a re-render on update. We can now see in the child classes the use of the binding property wrapper mentioned previously. That allows the current view state to be passed in from a parent view and can from there be manipulated. Also note the environment object set in each view. Even though the state data is an observable object, you cannot use the observed object property wrapper for a project-wide state, as with observed object, you are working with your own instance of the object. Meanwhile, with environment object, you are working with the same object. This is similar to using a static property contrast to an instance property. Now, after getting the top level initialized, I began setting up all the child views. This involves setting up the UI hierarchy, like getting the basic Z stack, which is your depth, and your V stack, which is the vertical aligned stack set, and setting up the view components. Creating separate components like this assists by removing duplicate code from the main view and helps with just tidying up the code base in general, which is always a benefit when you can modulate pieces of the UI, like in React or Flutter. Following the view setup, I set up the SpriteKit scene. This will be the base for the 2D game. I added a node for the background and a holder with 4 sprite nodes inside. I set the texture to a circle SVG that was imported, which provides better resolution at dynamic scales. After this, using the built-in SpriteView component to display the game scene object that was derived from the game scene class, which you will see me implement after finishing this view. Next up, adding a section that dynamically checks if the game is running, which is a variable set inside the game scene. And if it is not running, the view will therefore display the game's menu. After the UI was organized, I then added the onReceive methods, which then perform an update on the state variable depending on the event transmitted. Next, beginning work on the SKScene class, preparing some properties for use within the code. Using the didSet property observer to call the pass-through subject and send the updated data that has just been set. I'm using the inbuilt touchesBegan method to get touch locations and then check if the location is in the bounds of the current circle that is supposed to be hit. If a node is hit, the state is updated and the SpriteKit node color is set based off whether they are on, off, successfully hit, or missed. Subsequently, initializing some extra methods like the onPlayPress method, which is called externally when the play button is pressed. The method then places the game's values in a state, which allows for a new game to begin. Lastly, preparing the setup methods that will use optional unwrapping to set the circle holder and the background nodes to their respective reference on the scene. Now setting on the 3D scene for data rendering. Doing so by using a pool of objects pre-built so they don't have to be initialized at runtime, this helping performance. A feature which is slightly a hindrance is the fact that if you duplicate nodes on the scene, they will share geometry and the material they're using, which in an engine like Unity, they use prefabs which are selectively chosen to do behavior like that. After the scene is arranged, I lay out the custom scene view, which inherits from the UI view representable protocol. This allows for easier control over the view compared to using the inbuilt scene view, so you can set properties like the background if you desire. Now making use of my custom scene view to show the scene in SwiftUI, which can then be seen inside the preview on the right. Next, writing a setup data sticks method, which essentially grabs the material holder and data stick pool and unwraps them if they're found. Finally, setting the nodes to be positioned along the x-axis using the iterator count as distance, setting the stick's height based off the data for that tap during gameplay, and lastly, setting the color of the node based off whether the player scored or missed the last tap. And there it is, a build running on my iPhone that shows all the code and scenes being combined together to make one homogeneous iOS application build. Thank you for watching, and I hope you have a nice day.